Welcome to the Automation World Get Your Questions Answered podcast, where we connect with industry experts to get the answers you need about industrial automation technologies. And you can find even more answers by subscribing to Automation World magazine at subscribeaw.com. That's subscribeaw.com. I'm David Greenfield, Director of Content for Automation World, and the question we'll be answering in this episode is how to select the right valve for an application. And joining me to answer this question is Ross Turbeville, Senior Director of Global Industry Sales of Flow Control Products at Emerson Automation Solutions. So thanks for joining me today, Ross.
Thanks for having me.
All right, so let's get into it. Let's start the discussion by, just explaining the different types of commonly available automated valves based on the function and the effect the media to be controlled by the valve impacts a user's selection decision.
Yeah, so as we look at this and different type of automated valves, there's two big distinctions. You can have automated on-off valves, and then you can have control valves that are automated. And even if you look at the automated on-off valve space, there's what I would deem a general automated on-off valve, and then there's also automated on-off valves that go into safety instrumented systems. So those are a couple of distinctions people need to consider as they're looking at what is the valve and what's the function they want it to do. And then, if we look specifically at the control valve side of it, right, it's really looking at what kind of control resolution do you need? What does your system look like? And ultimately, with a control valve, you're trying to size and select a valve that has a characteristic that allows the system to be linear with an installed gain of 0.5 to 2.
Okay, thanks, Ross. So, what about valve sizing and performance based on flow, pressure, and temperature characteristics of the media that'll be moved through the piping system?
Yeah, so first and foremost, you need to be looking at it from a safety perspective. And when I talk about that from a safety perspective, what I'm looking at is what's the material capability from a corrosion, erosion perspective with the media that you're flowing. And then the second piece of the safety perspective is the pressure temperature limitations of a given material and making sure that the material and the pressure class rating you select for the valve meets code requirements to ensure that there's not a safety event that happens there. The second piece that you need to take a look at there is obviously the flow of the valve. So you've got pressure and temperature that also will play into the valve size depending on your pressure drop. But the flow also takes a big impact on what the capacity of the valve needs to be. So first, make sure that you select a valve that has material that can meet the media from a safety perspective with corrosion, erosion, pressure and temperature limitations. And then from there, you got to work to size your valve to make sure it has the capacity to handle the flow that you're looking at with that media.
So, how does the type of piping system used impact an end user's valve choice?
Yes, so the piping system used can impact the type of valve or what you want the valve to do in any given piping system. On the control valve side, when you look at the capacity of the valve, it's dictated by IEC standard 60534-2-3. And what this does, it defines the number of straight runs of pipe upstream and downstream of the valves, as well as sensor locations to allow measuring the capacity of the valve when you're in a lab environment. Anytime you get into a potential piping system that is compressed, there is also a risk of capacity of the valve could be different than the published values. It's also good to note that with the published values, the standards also allow a margin of error and the capacity dictated by the industry codes, right? And when looking at a piping system, understand what the piping system looks like, and then consult with your valve vendor if you have a very tight piping system to understand the impacts of that piping system. One great example we have learned at our Emerson Innovation Center in Marshalltown, Iowa, was related to the emergency cooling valve for the AP1000 nuclear reactor. We put together the actual system for the AP1000 reactor cooling valve, and the intent of this valve is to allow gravity flow of water in case of an emergency. So it's very important to the cooling. And what we found when we did this is this compressed piping system had a large impact on actual capacity of the valve in the system versus the theoretical capacity of the valve, and the impact that was there was a much reduced capacity of that valve inside the piping system.
Okay, thanks for explaining that, Ross. So, so far in our discussion, we've talked about, the effects of the media being moved through the piping, how that affects valve choice. You just explained how the type of piping system used impacts valve choices. But, how about when it comes to assessing the materials used to construct the valve itself? In that case, when you're looking at those materials, how does the media being controlled, the operating environment, and maintenance issues influence valve selection choices based on what the valve is made of?
Yeah, so the biggest thing there, beyond obviously material compatibility from a corrosion erosion perspective, is understanding what type of media are you flowing. Is it a compressible media? Is it a non-compressible media? Is it a clean service, or what I guess I would call a dirty service, where there may be debris in it? And then, looking at what's the pressure drop in that service, and what the valve design is. If you have a dirtier service with debris, obviously you'll want to stay away from any valve designs that have small drilled hole trims, because at that point you'll end up with more of a strainer in your line versus a modulating control device, or an on-off device where you can control the on-off. And then you've also got to look at from a pressure drop perspective and an ES and H perspective of what are the requirements around it. Do you have a noise restriction you need to meet, right? Are there other things going on in the piping system or the area around it where special considerations need to be met? What fluid are you flowing, and what does it mean from an emissions perspective? And then at that point, it'll allow you to select the appropriate valve design, whether that's a butterfly valve, a ball valve, or a globe valve when it comes to the control side. And then, on the on-off side of things, can there be a pressure drop or not? Does a butterfly valve make sense? Does a triple offset valve make sense? Do you need a full bore ball valve? And once you understand these things, then you can get into what valve is needed, work the details to make sure that you comply with all of the requirements that you may have in a given system.
So, since this is an Automation World podcast and we're speaking with you from Emerson Automation Solutions, we're obviously talking about automated valves here today. So, can you help explain the choice of electric, pneumatic, or hydraulic actuators for a valve and how a user can determine which is the best fit for their operation?
Yeah, so there's a couple different ways to look at this. And first and foremost, I would look at it from a performance perspective and how quickly a valve needs to respond to process changes, whether that's on the control side or on the on-off side, to make sure that the process is taken care of in the way it's intended with the design. And if we look at that, anything where you need quick response to a given process change or a command, you're going to need to be looking at a pneumatic or a hydraulic operating valve. If response time is less critical and it can take longer, then at that point you could potentially start looking at electric actuation. Now, the second piece that's really important with that is also what's the cost of the valve, what does maintenance look like, and what environmental safety and health considerations need to be taken into effect, right? If we look at the cost perspective, typically we're looking at hydraulic actuators as being the most expensive, then electric actuators, and the most economical actuators are the pneumatic actuators, right? And you also need to look at other things, is depending on what media you could be using to drive your actuator, what do emissions look like? In the upstream oil and gas world, if you're using gas to drive a pneumatic actuator, and especially with changing regulations, that may make less sense and you should go electric. At the same time, hydraulics, right, can provide extremely high resolution control. They can move very quickly, but they also have an oil reservoir that needs to be taken into account. What does the maintenance of that look like? What are potential environmental impacts? And what are other safety hazards or considerations that should be taken in place when you're selecting the actuator type?
Okay, so I noticed in your response there, you mentioned environmental health and safety issues, emissions regulations, and such. So, given that, I guess one last question here is, what codes, standards, or regulations should users pay attention to as they're going about selecting valves?
Yeah, so one piece that's been written by NTech to help look at what type of valve there is to select on the control side is they've written a specification called control valve dynamic performance specifications. And it walks you through a series of things to consider to determine what is the right type of valve and what is the right type of actuation system to select the best control valve for your process. So that's an important piece in terms of control and what you're looking at. But then also, if we just look at general industry standards and the important industry standards to consider as you're sizing and selecting control valves or automated on-off valves, is one, ASME B1634. That encompasses both control valves and on-off valves, and really is the design basis for what you need to consider or what a manufacturer needs to do when it comes to pressure boundary parts and making sure you have the correct wall thickness for each for each material type and the pressures and temperatures of that they can withstand. The second code that needs to be considered from an overall piping system is there's ASME B31-1, which covers power piping code, and B31.3 that covers process piping codes. These will all help make sure that the valves you're selecting meet code and ensures you have the best potential valve in place for safe operations. Then there's a couple of other codes where there's differentiation between control valves and on-off valves, and those are shut-off leakage class codes. So control valve shut-off is dictated by the standard that's FCI 70-2, while on-off shut-off requirement code is API 598. And those are two very important distinctions based on what you want your valve to do and whether you want it to control or you want it to be an isolation automated on-off valve. There are also other standards out there, most of them driven by IEC, that also relate to noise calculations and understanding the mitigation of noise within control valves.
Well, thank you for joining me for this podcast, Ross. And thanks, of course, to all of our listeners. And please keep watching this space for more installments of Automation World Get Your Questions Answered. And remember that you can find us online at automationworld.com and subscribe to our print publication at subscribeaw.com to stay on top of the latest industrial automation technology insights, trends, and news.